All right, so welcome back to another session. Right, for those who are watching this video, right, don't forget to like, share, and subscribe. Right, also remember that you can book a private tutor. Also remember we have customized worksheets, study guides, so you can reach out to us. And also, if you want to be a part of our Google Classroom, right, which is $100 per month, right, for per student, you can also reach out to us, and you get unlimited resources. Um, so in today's video, right, so Morgan, today we're gonna be looking at atomic structure. And before we do so, we're gonna do a recap of what we did in the previous session. But you remember anything from the previous session?
Sir?
You remember anything from the previous session that we did?
Yeah.
Tell me what you remember.
How we add the atomic number and the mass number.
Do we add the atomic number and the mass number though?
Sir?
Do we add the atomic number and the mass number? How do we get the mass number again?
Um mm, sir, add the protons,
Mm-hmm.
the neutrons.
Good. And the mass number is represented by which letter again?
Sir?
The mass number is represented by which letter? Which letter do the mass number is represented by?
Z. Z?
No. You have the notes in front of you?
Sir, A
Yeah,
A
A. Good.
and the atomic number Z.
Good, excellent. We're gonna do a review because right, we're gonna draw the structure, right? And once we get the basic concept of the structure, right, it's not something that is hard, right? It's something that once you follow the general principle, right, you should be able to draw it. But we're gonna look at some basic rules or some things that we need to go over, right, to go into today's session. So just tell me if you're seeing the PowerPoint that's on the screen.
No, sir.
Alright, so give me a minute. Alright, so you should know you're seeing it now.
Yes, sir.
Good. Alright, so remember we did the subatomic particles, right? We did that. So what we're gonna be doing, we're gonna also look at that as well. We're gonna do a recap. So let's go. So remember that in the particular theory of matter, which I'll be doing a video on that, right, pretty soon, right? Remember that the particular theory of matter also states that a matter is made up of particles which are constantly in motion. These particles entails atom, molecules, and ions, right? We haven't done anything with molecules and ions yet, right? But we'll do that right pretty soon. We're not gonna be focusing on that now. We're focusing on atoms, and we also want to know the structure of the first 20 or something. That is something that we need to know. So we did this already. We did right with these atoms is the smallest particle in which an element can be divided, and the reason why I keep on recapping is that right it's a refresher, right, to help us to go into the other part of the content, right? Just like history, right? The persons who were before us, right? We can't really deny what the word that they put in, so we have to acknowledge that and move forward. So particles that make up atom, right? What did we say three particles were again?
Sir? Proton, electron, and neutrons.
And one thing to take note of, what did we say about atomic number? Atomic number tells what and what exactly? What does atomic number tell?
The number of protons in the atom nucleus.
Good. As well as what? Tells protons, and it also tells what?
Electrons.
Excellent. So once we know the atomic number, right, we should be able to tell the amount of electrons in the structure as well. So if the electron is, if we have 20 electrons, right, or we have 20 protons, right, for argument's sake, we have 20p. So if we have 20p, right, how much E would be there? How much electrons would be there as well in the atom?
Sir?
If we have 20 protons in the structure of the atom, how many electrons would we expect to be in the structure?
20.
Good, because within an atom, the protons and electrons, they are equal, right, which make the overall charge neutral. So that's something to take note of. Did this already, right? Just to refresh our minds, let me just remove what's on the screen. Give me a minute. Yeah, man, so we did that, right? We did electrons, protons, neutron, right? We did where they are located as well as the charge. So we're not gonna spend any more time on that. So we have an understanding. You have an understanding of what's going on in terms of the three subatomic particles, right?
Yes, sir.
Good. Looked at this as already. It's all right. Look at this as well. And I did make reference to the atomic structure looking like the solar system. It's a bit pretty much similar, where the electrons move around the nucleus in energy levels, right? Or on shells. So the atomic number tells the amount of protons in the nucleus, and it also tells the amount of electrons. So that this can be added to that as well in the atom. The mass number, again, right? A equals Z plus N, right? So even if you write, I mean, if you write the definition, they ask you the definition, right? You can say that as well as you can put this below the definition. So the mass number equals Z, which is the amount of protons, plus N, which is the amount of neutrons. So N represents neutron and P represents the Z here, so represent the amount of protons, right, which would be the atomic number. So we should have that from yesterday's session. Now, in going deeper into the content, right, the arrangement of subatomic particles, right, remember that the protons and neutrons, they're present within the nucleus, right? So in the nucleus, you have P and N. Morgan, do you do geography? Are you doing geography?
No, sir.
And then on the shells, right, you have E. So these would be E. So in the nucleus, we have protons and neutrons, right? And on the shell, we have electrons. So this is just recapping. So if you're looking here exactly, right, right, you have a central nucleus consisting of protons and neutron, and then you have shells surrounding the nucleus containing electron. So just, right, you can take a note of this, Morgan, or a screenshot, either one.
Yes, sir. Yes, sir.
Screenshot already?
Yes, sir.
Well, when you screenshot, do you write off it in your spare time?
Yes, sir. I did a write off the last one. Them
Alright.
never finished though.
Yeah, man, this is gonna be important for the coming months, you know, so make sure you have it. Alright, so each shell has a fixed distance from the nucleus, right? And then electrons in the shell closest to the nucleus fill up first, right? And then each shell contains a fixed number of electrons. And I'll show you that in a few minutes. At this level, what you need to focus on. So the idea is that if you move on to do chemistry at a higher level, right, especially the cave level, right, you will learn you will go deeper into the subject as I mentioned before. So as you move up to each level, depending on what you're studying, right, you learn more stuff. So when you're at grade 9, you learn something different, not necessarily different, but something that's base level. Grade 10, you go deeper. Grade 11, deeper. Sixth form, deeper. And then if you move on to tertiary level to study that at college, you go deeper into the subject. Now, the idea is that it's on the CXE syllabus as well at this level, right? And you would see it in some books. At this level, you learn about each shell, right, and how much they can hold. When you move on to Cape, you learn about 18, 32, stuff like that. But at this level, because we're focusing on the first 1 to 20 elements. And so the first shell, right, I think you should take note of this. The first shell can hold 2, the second shell 8, right, the third shell 8, and then the fourth shell 8. So these are the maximum the shell can hold. As I said before, when you move on to higher level, you learn about 18, then 32, stuff like that. But at this level, just need to know about this for now. When you learn about SPDF notation, but you don't have to worry about that. So the first shell hold 2, second shell 8, third shell 8, and then the fourth shell hold 8 as well. Because we're not gonna go over we're not gonna go over more than 4 shells at this level. So the fourth shell can hold 8. So just take note of that, Morgan.
Yes, sir.
I would prefer you write it down. I would prefer for you to write it down. But either one works for you if you want to screenshot. Also remember that all the videos, right, post it on the YouTube channels. So we're building that YouTube channel as well, so you can watch all the videos, right? If it is that you have problems with a topic, you know, rewatch the videos on YouTube. Ready, Marvin?
Yes, sir.
Alright, let's continue. Hold on a minute. Alright, good. So steps in drawing shell diagrams, right? Because we're moving into that pretty soon. So the first step, you're gonna determine, right, the protons, neutrons, and electrons in the structure using the atomic number and the mass number. We know how to do that, right?
Yeah.
Good. Which is the same. So you see how many times we're gonna use this formula. A equals Z plus N. So that's the first step. We're gonna determine the protons and electrons using the formula. Protons, neutrons, electrons. As I said before, right? Once you know the amount of protons, right? The atomic number tells the amount of protons as well as electrons in the structure of the atom, which is gonna result in the overall charge to be 0. Both of them are equal. Remember, the charge on protons is positive, the charge on electrons negative, and then the charge on neutrons neutral. So both these two will contribute to the overall charge. So once they're equal, both of the charges are going to cancel out each other, which is going to make the overall charge on the atoms neutral. If I'm missing a particular point, just tell me to hold on, go back over. So just let me know if you get a particular part. The second step, you're gonna draw a small circle for the nucleus. So this is right here, you can take out. So you're gonna draw a small circle for the nucleus and write the number of protons and neutrons in the nucleus inside this circle, which would be something looking like this, as you always see me drawing. You have N and P. So after you work that out, using the mass number and the atomic number of the symbol that you're seeing on the periodic table of a particular element, you're gonna now go ahead and determine the protons and neutrons using the same formula above. After you determine that now, you're gonna write the amount of protons and the amount of neutron. So for argument's sake, just using an example, you work one out, right, and you get 5n for 1, just for argument's sake. But not argument, for demonstration's sake. And then you have 5p. So what you normally do, after you work that out, using this formula, you're now gonna write the number and beside the n and beside the p. So you get that?
Yes, sir.
You're sure?
Yes, sir.
Alright. Then you're gonna work out the electronic configuration by filling up the shells with electrons in order. So I'm gonna, you don't need to worry about this. I'm gonna explain. So you work out the electronic configuration by filling out the shells with electrons. So the idea is that you have to ensure that each shell is filled before you move on. So remember, the first shell can hold a maximum of 2. Second shell, 8. Good. Third shell, 8. And then the fourth shell, 8 as well. So if it is that, for example, for the second shell you get 4, you can't move on unless it's filled. However, you have to ensure that you're gonna fill it, you're gonna work with that using the amount of electrons in the structure. So for example, you work out the amount of electrons to be 6, right? The first shell, you ensure that the first shell is filled, which would be 2, and then the second shell would be 4, right? Because 4, 5, 6, you can't do anything else, because this is the amount of electrons that is present in the structure. So it's not a case where you're gonna say, all right, 2, 4, or 2, 8, and then you just randomly add numbers. It's not a case like that. You have to ensure that you work based on the amount of electrons that you find or that you work out to be in the structure of that atom. Say if the atom has 6 electrons, right, you have to show the 6 electrons it has to add up back to the 6 electrons, which would be 2 and 4. So the first shell is already filled, right? So it can't hold anymore because it can hold a maximum of 2. So the second shell now can hold the 8. The second shell can hold the 4 remaining of the 6 that you have, because it can hold a maximum of 8. Are you following, or should I go over that section?
Sir, but okay, I understand.
So as I mentioned, the first shell can hold 2. So once you write the 2, right, you move on to the second shell and you write the amount remaining. You get that?
Yes, sir.
If we have any more here, and then we can work out some on the blackboard. So let's clean out what we have. Now represent the electric configuration by drawing circles around the nucleus. You don't have to worry about the concentric circles. You don't have to worry about this word concentric. Don't worry about that. Just draw circles around the nucleus. Now use cross or dot to represent electrons, right? I did a video on that as well on the YouTube channel, showing the difference between dot and cross. So just to summarize, this would be the cross. So you're gonna use either to represent the electrons on the structure. So you see, so this would be dot, this one would be dot, and then the top one would be cross. So this is basically how these are the symbols that you use to represent electrons. So you can use either one. You can use the dot or you can use the cross. You get that?
Yes, sir.
Let's draw it properly. So that just like a full stop, right? And then the cross, similar to the asterisk. When we draw into the structure, when we draw in the structure, I'll tell you, like, in terms of allowing it to be organized, right? In terms of you start out single first, then you pair. But we're just gonna do review these steps, right? And then we're gonna work out some. You want me to go back over the steps or you get that?
Sir, I understand.
Good. Now, the next part we are the next objective, which would be EC, right? And the reason why we're doing it like this is because both of the terms they are tied together. It's similar. The atomic structure EC, right? They work hand in hand. Now the EC, this basically shows how the electrons are arranged on the shells, right? So for example, when you draw the electronic structure of the atom, right, you just write in how much electron is present on each shell. So for argument's sake, on these, you just the shortened form, you do just use EC, that between the E and the C, and that at the end, the full stop. So the EC here would be 2, 4, right? So for example, let me just give you a quick symbol, quick demonstration here. In other words, you're just writing what's on each shell in the structure. So for example, 2 electrons is on the first shell after you draw it, and then on the second shell you have 4. Yeah, man. So it would be something similar to this, right? You're just writing what's on each shell. That's what we EC mean. So you count the total on the first shell, which would be 1, 2. Then I write this down because the first shell have 2, right? 2 is on the first shell, and then the second shell 4 is present. So it'd be 1, 2, 3, 4. So in other words, if you want another way to remember, right? The EC is just telling you the total amount of electrons on each shell. So it's not a case where you're just gonna write more than 1 or you write 4. Yeah, you have to write it based on the amount of shell you see in the structure, because both of them, you have to ensure that it works hand in hand, right? So that's how it works. So 2, first shell have 2, fourth shell, second shell, right? 4. So that's how the EC works. EC shows how electrons are arranged on the shells in an atom. Get that?
Yes, sir.
Alright. So what we're gonna be doing now, right? Because we have around 4 minutes remaining in this session, right? What I'm going to do, I'm just gonna do a quick recap of what's going on, and then we will join the other session where we'll start drawing the structure. Until next time, peace.